Okay guys, chapter 2, section 2 is reference angles. And a reference angle is written as theta prime. So it has that little tick mark by it. And that's read as theta prime. It's a positive acute angle, so it's between 0 and 90 degrees. So your reference angle is always going to be in that first quadrant. So in order to find the reference angle, we're going to look at example 1, finding the reference angle, 218 degrees. So 218 degrees is in the third quadrant. If we look down here at the bottom, in order to find theta prime, it has to go by the quadrant. So if we're in the third quadrant, it says if given theta in quadrant 3, then theta prime equals theta minus 180 degrees. So 218 degrees is in quadrant 3. So we're in Q3. Since we are in Q3, we're going to say theta prime equals 218 minus 180. So when we subtract that, we have 38 degrees. So that's your reference angle. It's between 0 and 90. It's in the first quadrant. If we look over here at B, this angle is over 360 degrees. So just like we did back in chapter 1, section 1, anytime an angle is over 360 degrees, we have to subtract 360 until we get it between 0 and 360 degrees. So if that's the case, since it's 1387, I'm going to subtract 360 times 3, which is at 1080, which equals 1080. So I'm going to subtract 1080 from 1387. So 1387 minus 1080 gives me 307 degrees. 307 degrees is now in quadrant 4. So I'm again going to look down here. If given theta in quadrant 4, then theta prime, your reference angle, equals 360 minus theta. So in order to find theta prime, I'm going to take 360 minus 307, and theta prime is going to equal 53 degrees. Okay, so let's look at these rules. These are important. They're going to be need to know. In order to find your reference angle, if given theta in quadrant 1, so if your angle given to you, like 218 or 1387 was given to us, is in quadrant 1, then theta prime just equals that angle, because that angle is already between 0 and 90. If it's in quadrant 2, so if given theta in quadrant 2, then in order to find the reference angle, you're going to take 180 minus theta. If it's in quadrant 3, like 218, theta prime equals theta minus 180. So quadrant 2, you're subtracting from 180. Quadrant 3, we're subtracting 180 from our given angle. And then in quadrant 4, theta prime equals 360 minus theta. So those are important. 4 things to jot down, definitely. Looking at example 2, we want to find trig values of a quadrant 3 angle. So it's given us 210 degrees. So 210, if we draw it, we're in quadrant 3. The first thing we want to do is find its reference angle. So since we're in the third quadrant, we're going to say 210, your theta, minus 180. That's going to give me my reference angle. 210 minus 180 is 30 degrees. Something should be, bells and whistles should be going off in your head. 30 degrees, we just talked about that in section 1. That's one of those important angles. They're a special right angle, special right triangle angle. You got that 30, 60, 90, and 45, 45, 90 triangle. So 30 degrees, bells and whistles should be going off and be like, Miss McAllister told me to write down this chart on page 52. So that's what I'm going to do. I'm going to look at my exact value chart from page 52. Group A, you got to put it on a note card. Group B, remind me to have you guys put it on a note card on Thursday. So you're going to look at the exact value chart on page 52. You're then going to fill in the function. So we're going to look at 30 degrees on that exact value chart. The sine of 30 degrees is 1/2. So yes, this says the sine of 210, but remember, 210's reference angle is 30 degrees. So I'm just going to pretend that these say 30 degrees. So the sine of 210, we're going to put 1/2 because the sine of 30 degrees is 1/2. The cosine of 30 degrees is the square root of 3 over 2. The tangent of 30 degrees is the square root of 3 over 3. Cosecant, we're just going to flip. It goes with sine, so that means we'll have a 2. Secant, we'll have 2 square roots of 3 over 3. And cotangent, we'll just have the square root of 3. Now, we're not technically dealing with 30 degrees. 30 degrees just gave me these values that I filled in. I'm dealing with 210 degrees. 210 degrees is in the third quadrant. Third quadrant angles have negative sine and cosine. So I'm just going to come through and throw a negative sign in front of my sine and my cosine values. And that means that their reciprocals are also negative. So 210 degrees, the sine of 210 is negative 1/2. The cosine of 210 is negative square root of 3 over 2. Tangent is positive, so it's still the square root of 3 over 3. Cosecant would be negative 2. The secant of 210 is negative 2 square roots of 3 over 3. And cotangent is the square root of 3. So again, given an angle in something other than the first quadrant, you're going to find the reference angle. And as long as it's something that has one of those exact values, you're going to look at the exact value chart that's on page 52 of your book. And then you're just going to fill in the functions for that reference angle and then add in the negatives where appropriate. Example 3. We're going to find trig functions using reference angles. So I want to know what the cosine of negative 240 is. And you're probably thinking, Ms. McAllister, I can just type that in my calculator. Well, yes, you can, but sometimes you don't always have that calculator, aka the STAR test, or sometimes on the SAT or ACT, they're going to think that you already know those reference angles. So, first of all, this is negative. We're not dealing with a negative angle, so just like before, we have to find the coterminal angle. So I'm going to add 360 degrees to this. So that means I'm now technically looking for the cosine of 120 degrees, which is in quadrant 2. Since I'm in quadrant 2, I need to find that reference angle. Theta prime equals 180 minus theta, which is 120, which is going to be 60 degrees. So my reference angle of negative 240 is 60 degrees. I now can look at that exact value chart and say the cosine of negative 240, okay, is the same as the cosine of 60 degrees, which is 1/2. Negative 240 is in the second quadrant. That's what this told me, finding my coterminal angle. Since it's in quadrant 2, the cosine value is negative in quadrant 2. Part B, tangent of 675. It's over 360, so I'm going to subtract 360 from 675. And I'm now going to look for the tangent of 315 degrees. So that's my coterminal angle. 315 is in quadrant 4. Since I'm in quadrant 4, in order to find theta prime, I'm going to take 360 minus 315, and that's going to equal 45 degrees. So again, going to look at that handy-dandy function chart, exact value chart. And at 45 degrees, the tangent value of 45 degrees is 1. So the tangent value of 45 degrees is 1. Since I am in quadrant 4, tangent is negative in quadrant 4. So the tangent of 675 is negative 1. Example 4. I want to evaluate this expression. So I have the cosine of 120 plus 2 times the sine squared of 60 degrees minus the tangent squared of 30 degrees. So only angle I have that is between 0 and 90 to give me an exact value are 60 and 30. Those two I don't need to touch. This cosine of 120, this angle is greater than 90 degrees. So I want to find its reference angle. So I want to find theta prime for 120 degrees. 120 is in quadrant 2. So I'm going to take 180 minus 120. And my reference angle is going to be 60 degrees. So theta prime equals 60 degrees. The cosine of 60 degrees is 1/2. Since it's in quadrant 2, it's negative. Since 120 is in quadrant 2, I should say, it's negative. So I found my reference angle, used that exact value. The cosine of 60 is 1/2. Since 120 is in quadrant 2, I'm going to throw on that negative sign. I'm then adding 2 and then the sine of 60 degrees. Sine of 60 is the square root of 3 over 2. Again, I just pulled that from your exact value table. So the sine of 60 is the square root of 3 over 2. And since sine is squared, what's in parentheses is squared. And then I'm going to subtract tangent squared of 30 degrees. Tangent of 30, again on the exact value table, is the square root of 3 over 3. And that will be squared.